Solving polynomial equations, difference of squares, and sum and difference of cubes. These are some of the basic perfect squares from 1 all the way to 144. You should know these perfect squares so that it's easier for you to work with these problems, or at the very least know how to find square roots in your calculator. So let's talk about the process of using difference of squares. So this is a special way to factor, and you can only use it with certain types of quadratics. So first, it must be a subtraction of exactly two terms. So you want to make sure you look for that subtraction symbol and you have one term and another term. Second, both terms must be perfect squares. So it's kind of in the general form, some number squared times x squared minus another number squared. So if you look at this, 4 and 9 are both perfect squares. That's why it's important to have your basic perfect squares memorized so you can tell really easily. So our next step, take the square root of both terms, which means find a, x, and b. So when we take the square root of 4, that gives us 2. The square root of x squared gives us x, and the square root of 9 gives us 3. Now you can do some of these steps in your head, but I'm just showing you how to find each of our a, x, and b. Then, for your answers, your factors will consist of the sum and difference of these two factors. So remember, sum is addition, difference is subtraction. So we want to write it in the form ax, which is going to be 2 times x, and then one of them is going to be minus that last one, 3, and then the other one will be almost exactly the same, except we're going to have a sum, a plus sign instead of a subtraction separating them. So this is going to be our final factored form of 4x squared minus 9. Now let's work out a few examples. I'll do this first one with you. So when you look at this, we don't really have an a. You can consider it as positive 1, but remember, we want to double check and make sure first it's a subtraction sign here. We have two terms, and each of these needs to be a perfect square. So the square root of 1 is 1, the square root of x squared is x, and the square root of 144 is going to be 12. So we're going to take these terms and then we write 1 with the subtraction sign and then 1 with an addition sign in between them. And then we're finished. This is the factored form of x squared minus 144. So I want you to pause, try example 2 and 3, and check back with me when you're finished. For example 2, when we check for that subtraction symbol, it's there. It is two different terms, and then we can find square roots of each of these perfect squares. So square root of 25 is 5, square root of x squared is x, and square root of 16 is 4. Then when you write your final answer in factored form, 5x minus 4, and then 5x plus 4. Now for example 3, hopefully you got that it was not factorable. It fails in the very first step. This is an addition symbol. It is not subtraction, which means that you cannot use difference of squares with this. So remember, you have to be careful, and that's what it stands for, difference, which is subtraction, of squares, the perfect squares. So make sure you look for that subtraction sign, and if it's not there, you can't factor it. So now we're going to talk about perfect cubes. 1 through 216, these are some of the basic ones. So if you do have these memorized, it'll help you identify cube roots or perfect cubes a little faster. If you don't know them, then at least make sure you know how to find them in your calculator. Sum and difference of cubes. So you need to note that this one is just slightly different from difference of squares because sum is also an option. So in our first step of checking to make sure we can use this, it must be addition or subtraction of exactly two terms. So it doesn't matter whether it's addition or subtraction, but again, we're only working with two terms. Then, secondly, both terms must be perfect cubes. So again, 8 has to be a perfect cube, and we need to see x cubed, and then that last number, 125, also needs to be a perfect cube. So our first step is to take the cube root of both terms. So again, we're going to take that cube root of 8, which gives us 2, the cube root of x cubed, which is x, and the cube root of 125, which is 5. And again, you don't have to write this out every time, but I'm just doing it to show you we're taking the cube root of each thing. And then in step 4, we want to rewrite the terms as multiples of the cube roots and group them in pairs. So the way you see it written here, ax times ax times ax. So we take that 2x times 2x times 2x, and then b times b times b. So we have 5 times 5 times 5. So we're basically rewriting this. And then we want to group them in pairs. So the first two, the middle two. Oops, I cut that off there. Let's try that again. The first two, the middle two, and then the last two. Okay. And then after that, our factors will consist of one binomial and one trinomial. The first one, the binomial with two terms, is going to have those cube rooted terms. So one of them will be 2x and 5. And then the way you're going to get the trinomial, the one with three terms, is you're actually just going to multiply each pair. So multiply the 2x times 2x, and that'll give you 4x squared. The 2x times 5, and that'll give you 10x. And then the 5 times 5, and that gives you 25. Now, the last thing we need to do is go in and put our signs, whether each one is going to be plus or minus. So I know this might look a little confusing, but I want you to remember SOP. Same, opposite, positive. So what that tells you is, in the very first one, the binomial, it's going to be the same sign as the original question, plus. O for opposite. Whatever this was, make this the opposite, negative. And the last one is always going to be positive. So here is our final answer using sum and difference of cubes to factor that. Now we know that we can further factor this one, so we actually end up with 3 binomials, but for now we'll just stop here. So let's work out a few examples together. Example 1, we're going to go through the process again, so check to make sure we can actually use it. We have either an addition or subtraction symbol, and we have 2 different terms, and they all need to be perfect cubes. So x cubed can be rewritten as x times x times x. 125 can be rewritten as 5 times 5 times 5. And so since they are perfect cubes, then we want to go ahead and do our grouping. First 2 terms, middle 2 terms, and last 2 terms. And then when we write our final factored form, we have, it really is going to end up being that middle term, but it's one of each. You have x and 5. And then you multiply the first pair, x squared, the second pair, 5x, and the third pair, 25. And then when it comes down to the signs, remember, the first one is the same, second one is opposite, and then the last one's always positive. Remember, SOP. So here's our factored form using difference of cubes. So I want you to go ahead and try example 2 and example 3 and check back with me when you're finished. So hopefully for example 2, you found that it was not factorable. Even though x cubed and 8 are both perfect cubes, 201 is not a perfect cube, so we actually cannot use sum or difference of cubes to factor this. And actually, if you were to try any other method, it also doesn't factor. So the only way you'd be able to solve for x is to use the quadratic formula. In example 3, 27x cubed can be broken down to 3x times 3x times 3x. 64 is broken down to 4 times 4 times 4. And then for our very first binomial, you take those middle terms, 3x and 4, and then in our trinomial, multiply the first pair, the second pair, and the third pair. And then lastly, when you go in for your signs, you want the first one to be the same as the original, the next one to be opposite, and the last one to be positive. So don't forget, with sum and difference of cubes, sup. That's it for today. Submit any questions if you have any, and I'll see you in class.